In this video, we're going to continue to talk about the unit circle. This is the second explanation. This is Desmos.com. This is a unit circle. So there is a unit circle built into the website right here. I took that, I made a couple edits to it. So using this, let's discover the unit circle together. All right, so we are staring at a blank graph. We have a y-axis, we have an x-axis, but we don't have anything drawn. We don't have any points plotted. So let's start doing some of that stuff. Let's draw an angle of 30 degrees. Now, just to be clear, I mean this here is 30 degrees. Now, you may be wondering, how do I know that that's 30 degrees? Well, the program tells us right here, right? So A stands for angle. And yeah, it's saying that the angle equals 30 degrees. And then there's this really cool slider that we can use to adjust how large the angle is if we want to. So that's kind of cool, right? I will link this unit circle in the description below so you can see it and play around with it if you want to. But let's see, can we make an angle larger than 90 degrees? Yeah, we can. Okay, cool. We can even make it larger than 180 degrees. So just to be clear, this is 227 degrees, right? This here, that didn't draw correctly. This angle right here is 227 degrees, right? Just to be clear. Okay, cool. So let's go back to 30 degrees. So let's start talking about sine and cosine. What is the sine of 30 degrees? What is the sine of 30 degrees? Well, if you don't know that off the top of your head, then we should use a calculator to figure out, right? So I guess we'll use the calculator that's just built into Google. Okay, so here we are. Let's make sure our calculator is in degree mode, and let's do sine of 30. 0.5. Okay, 0.5. Now, what about cosine of 30 degrees? Do we know what that is? Well, let's use a calculator. Cosine 30. Oh, that is not a nice number. Let's round it to 0.866. Okay, let's go back to the graph. So let's see, we got an angle here. We talked about sine and cosine. We still don't have a circle though. That's pretty important, right? This is supposed to be the unit circle. So let's draw a circle. This is a circle of radius 1, okay? And believe it or not, that's actually what the unit circle is. That's just like the unit circle is as simple as that. The definition of a unit circle is a circle with a radius of 1. So what is the length here? What is this length here? That length would be 1, right? That would be 1 because that's the radius of the circle. And you can even see here, they literally have 1 up there, right? That is 1 on the y-axis. So let's talk about coordinates of points on the circle, because that's like an important thing for the unit circle, right? So what are the coordinates of this point on the unit circle? Well, that would be 0, 1, right? The x coordinate is 0, the y coordinate is 1, right? Okay, what about the coordinates of this point on the unit circle? Well, that would be 1, 0, right? And I think actually the program should tell us the coordinates of the points. Yeah, 0, 1. Well, what about this point? This is the line is intersecting the circle here. That seems like maybe that's an important point. Do we know the coordinates of that point? There's the point. The program put that point there. Now, who knows what the coordinates are? They could be like random decimals for all we know. So you're probably not going to be able to guess them like exactly, but just take a wild guess. If you want to take, a few seconds to think about it, feel free to pause the video, but just take a wild guess as to what the coordinates of this point are. Okay, let's click on the point. Let's see what the program says. 0.866, 0.5. Wait a minute. Those numbers are the same that we have down here. Oh my goodness. Is that a coincidence? The cosine of the angle is the x-coordinate of the point. The sine of the angle is the y-coordinate of the point. That's why people care so much about the unit circle. This works for literally any angle. So let's choose another angle just so you can see this. We did 30 degrees, but let's do another angle. Let's do, I don't know. Let's choose that 107 degrees. So to be clear, this right here is 107 degrees. What is the sine of 107 degrees? And what is the cosine of 107 degrees? Who knows, right? So let's ask the calculator. I think we can erase this. Okay, so let's do sine of 107 degrees. Sine 107. Okay, that's not a nice number, but let's round it to 0.956. And then let's do the cosine of 107 degrees. Cosine 107. Also not a nice number. It's a negative number. Okay, so negative 0.292. All right. Now, I wonder what the coordinates of this point are going to be. I guess the previous example kind of gave it away, but take a wild guess. All right. 0.292, negative 0.292, and 0.956. Wait, what? It's the same as these numbers, right? Okay, so cosine corresponds to the x-coordinate, right? Sine corresponds to the y-coordinate. That's why people like the unit circle so much. So let's write that. Let's write that down. Sine of an angle, any angle, is the y-coordinate. Okay. Cosine of any angle is the x-coordinate. All right. That's so important. And in fact, that is your new definitions of sine and cosine. So previously, like in geometry, you have defined sine as like opposite over hypotenuse in a right triangle, right? And you would have defined cosine as adjacent over hypotenuse in a right triangle. But we have new definitions now. We have new definitions. These are better definitions. Sine is the y-coordinate. Cosine is the x-coordinate on the unit circle. These previous definitions here, these were fine. They're fine definitions. But these new definitions that have to do with the unit circle are better. They are superior definitions. And I will talk more about why those are superior definitions in the next video. Thanks for watching.